Welcome to Hastings Math videos. This is the October 2020 International A-Level exam, and I'm going to be going through question 5, which deals with trigonometry identities and integration of the trigonometry identities that we will work out in question A. So question 5 is over here. If you want to just have a quick look at the mark scheme and give it a go before we start. That's the mark scheme. So that's 5A and 5B. Okay. Question 5A says show that the left-hand side over here equals to the right-hand side. So we want this equal to this. So sine 3x is our left-hand side, and we want it to equal 3 sine x minus 4 sine cubed x. Okay. So if you want to go ahead, this is the mark scheme. First thing we do is we split this 3x up. Okay, so we can't integrate that straight away. I just want to check if this is the exact same thing. So this is what we're aiming for. That's our right-hand side. Okay. So we split this up. We can't do anything with this like this. So we just split it up. And we split it up. Well, 3x's is just 2x's plus another x. Okay. So first step, know that sine 3x is just 2x's plus another x. And then we take a look at our identities. This one is on the mark scheme. So we know sine x cos x plus cos x sine x is going to be sine of, oh, let's make this y. Okay, sine of x plus y is going to equal this whole thing. But our angles are different, so we're going to be having sine 2x is our x value. So this 2x is in our x position. So sine 2x cos x plus cos 2x sine x. So just to track that x has gone in the y position over there, and the 2x has gone in the x position. Okay. So what do we do from here? Well, we want to change the double angle formula. So the next thing we need is our double angle formula. I can already see there's a double angle over here, and there's a double angle over here. So look at sine to x first, because there's only one option. Sine to x is 2 sine x cos x. It's always that. Okay. Cos to x has 3 options. The option that cos to x, the option that they've used is pick one. So you got to pick one. I think the hard part is picking there's no necessarily a right one, but if you were to pick one of them has both cos x and sine x in it. Just want to grab them for you. Here are from a previous question in this paper. If you just look at sort of over here, how you get these double angles, the full proof is here. So just manipulating the compound angle formula, putting instead of a and b, you put x and x, and then you can manipulate it into 3 different ways. So the 3 different ways is cos squared x minus sine squared x. This one I don't use very often. Or it's 2 cos squared x minus 1, or 1 minus 2 sine squared x. So these are the 3 options. And you can see from the mark scheme that they chose to use this one. And I tend to agree. So the goal is always to sort of manipulate further. So I would have either used this one or this one. I think I'm looking at it, it's got sine and cos in. So I would have gone for either this one or this one. I'm going to follow the mark scheme. So we're going to use the 1 minus 2 sine squared x version of it. So what am I doing is basically wherever I see cos squared x, I'm instead putting this. And wherever I see sine squared x, I'm instead putting this. Okay. So sine squared x is 2, sine x, cos x now. The cos x is still there. Plus 1 minus 2 sine squared x. And that sine x was already there. Okay. So this is what we've got now. Next step, just let's times it in, see if there's anything we can group. So I see over here we have a cos x times a cos x. So for me, that's just cos squared x. So 2 sine x cos squared x. And on this side, we just times this plus in. So plus 1 minus, oh, hang on a second. I should probably do this the correct order. So first you want to times it out. You don't want to do what I just did. So no, first you want to, let's do that. So times the sine x in, because multiplication goes first. Okay. So we're going to end up with plus sine x minus 2 sine cubed x. Okay. So we got rid of that bracket. The next thing I would do is take out, try to either take out a common factor, but going according to this mark scheme, things that I would try and do is I would maybe take out a common factor here, and then see if I could further simplify. But remember, we're always aiming for this right-hand side. We want it to look like that. So that doesn't have a common factor out. So I'm not going to go that route. Oopsie. Next thing we can change is the cos squared x. Cos squared x plus sine squared x equals to 1. So then that means that cos squared x is equal to 1 minus sine squared x. Is a manipulation. So wherever we see this cos squared x, we can instead put this. So 2 sine x, 1 minus sine squared x. This works because now we only have sine, and we only have sine in the answer. So we got rid of all of our causes. Just bring down all my other stuff here. Okay. This should have an x there. I'm going to times this in, see what happens. 2 sine x minus 2 sine squared x's plus sine x minus 2 sine 3x. Nearly there. So I see a like term. This and this. What did I do? Hang on. This, something's wrong with it. So this times by this one, that should be a 3. Okay. That should be a 3. This is sine x times sine squared x. Okay. So our like terms, 2 sine x plus another sine x is 3 sine x's. And then negative 2 sine 3x minus negative 2 sine 3x is going to be negative 4 sine 3x's. And that, I think, is as we're good. Okay. So this is the finish for question, what was this? Question 5A. Question B. So we rearranged it to look like that. Let's take a look at 5B. So 5B says hence. Hence means like following on. Find the following. So first thing I see is we have the integration of an actual value from an actual value. So this is a definite integral. And then I know we're going to follow on from the previous question, but my previous question doesn't look exactly like this. So I have to find, it's not like they just stuck the left-hand side in here and you can replace it with the right-hand side. That's not what happened. Oh, glitchy pen. Okay. So normally, if you're lucky, they just stick this sine 3x over here. Let's highlight that. Oh, there we go. They would just put that in your integral, and then you can just replace it with the right-hand side. But we don't have that situation. So we have to manipulate it first. So we got our right-hand side is here. That was our right-hand side. And what they've asked for is a piece of the right-hand side. So I can see that this is inside the right-hand side. So let me quickly rearrange that. So we know that sine 3x is equal to 3 sine x minus 4 sine cubed x. And if we rearrange this, we get sine 3x minus 3 sine x all over -4. And that is our sine 3x. So now we have the correct thing that we can integrate. And that we just, if we manipulate this a little bit to look a bit prettier, it should be, oopsie daisies. -4 in the denominator on this side would be -1/4 sine 3x. And then negative and a negative is a positive, and it's 3/4 sine x. So our integral is, we can work with this one. So we're going to integrate between 0 and pi/3 for this whole thing. Okay. So this is what we're working with. The sine x you can do pretty easily. So I'll grab the mark scheme. This one we can do straight away because sine goes to cos. This one a little bit more complicated. So let's take a look, follow on. So take a look at the mark scheme. First step was, how did we even get to this thing? So that's how. They've got it reversed. So I'm just going to reverse it so I can follow on exactly. Okay. Let me reverse it. They just switch these around. So 3/4 sine x minus 1/4 sine 3x. Wait, this is what we want to be integrating for number 5b. Oopsie, that's pi/3. Okay, what do we do? Well, sine goes to cos, but in the negative. So the first one will be this. If we were to immediately integrate, this one on the left, we can straight away do, because sine, we know that sine just turns to cos. So we bring down the 3/4, and it's negative now. Okay, so that's sorted. You don't need to worry too much about that. But let's take a look at sine 3x. If I just take the sine 3x and take a look at this, it's actually, hang on a sec. What am I doing here? Okay, so if we integrate this, it's just going to be, bring down the 1/4. Then you want change this to cos, change the whole thing to cos. Oopsie. And then you have to divide it by the differential of what's inside the brackets. The differential of what's inside the bracket is just going to be 3. Okay, divide by 3. So if I put that into, sorry, sine goes to negative cos. So if I put that in here, this negative was already here. So it's negative. 4 times by 3 is 12, because we divided by the 3, and then cos 3x. Okay, good. Negative and a negative, it's just it's a positive, so that should work. Now, don't forget, if you put your Your 0 goes at the bottom, same order, same order. Okay. Top is first. Top is first, bottom is second. So open up your brackets, and then you're going to be minusing the one with 0 in. So the first one, 3/4 cosine pi/3 plus 1/12 cosine 3 times pi/3. And this can just go in the calculator, or you can do it bit by bit. Just be careful, obviously. Oopsie, that's still negative. This was a negative, 3/4 cosine of 0 and 1/2 cosine 3 times 0 timesing by 0. Okay, all of that in, and you should get a nice answer of 5/24. Just going to check that quickly before I finish up this question 5. Just to clarify, I was checking if this would be the answer. What I did is I first worked out, so I stuck, you can put this whole thing in your calculator, but I first stuck cos pi/3, get that. Cos 3 pi/3 is actually just cos pi, get that. Cos 0 is 1, and then this also cos 0 is 1. And then this can go in the calculator in one go, and it did indeed come to 5/24. That's finishing, that was question 5B of the 2020, I think October or June exam for the international A levels. Good.